Hello, boys and girls. Let's take a short review of the formulas and then move on to something else. Some people told me they're a little confused with the homework today. If you know the formulas and if you know the formulas, you're going to know how to work out the volume of the prisms you're given. Sometimes you're given the length and the width and the height. Then you can use length times width times height. Then you get the volume of the rectangular prism. Sometimes it's a cube. Then if you know the edge, you can multiply the edge by itself 3 times. Sometimes you're given the base, the area of the base, then it's the area of the base times height, because length times width is the area of the base. So depending on what you're given, you can choose one of these formulas. For the area of a prism, we never talked about a formula. We just talk about the area, the surface area of a prism is the sum of all the faces, the sum area of all the faces. In case you need it, what you can do with the formula is, if you know the length and width and height, you multiply each two, length times width, then length times height, then width times height. These are each of the 3, we know that there are 3 pairs of congruent rectangles in each prism. So these are one of each 3 congruent pairs. Then you add it up together and times 2, then you get the surface area. Surface area it can be confusing sometimes. You have different prisms. So the key point is to add up the area of all the faces. If you remember that key point, you're going to be able to figure out the surface area. Since you already know the area of a triangle, the area of a rectangle, then you're able to find out the surface area of a prism. For today though, we are going to work on the volume of liquid. We hope to learn how to find the capacity of a rectangular prism, and we hope to solve problems involving volumes of rectangular prisms and liquids. We talked a little about capacity when we started this chapter. So if you look at this rectangular prism, actually a cube, you will notice that the cube can hold more water than it has now. It has a little bit of water and there's some empty space. So capacity is the ability of the cube to hold water. So the capacity of the cube is the whole volume of the cube. Edge times edge times edge is 3,375 cubic centimeters. That's the capacity, how much water it can hold. However, for now, the volume of the liquid is not that much. It has only 5 centimeters high. So the volume of the water is 15 times 15 times 5, the volume of this part of the cube. You can consider it another rectangular prism. So the volume of the liquid is 1,125. And if you do subtraction, you will know the volume of the empty part. Sometimes you are asked to fill the tank, how much water you need to fill the tank completely. Then you will know how to do it. However, when we talk about liquid, cubic centimeter is not a perfect unit measure for liquid because centimeter is a measure for lengths, not for volume of water. So we want to convert cubic centimeters to milliliters or liters. Let's see how to do it. Well, if we were at school, we might be able to experiment on it. But now I'm just gonna show you how they did it when they find when other people found how to convert milliliters and cubic centimeters. This jug has 1 liter of water, which is also 1,000 milliliters. So that's the liquid. And what they did is they poured the liquid into the cube. The cube measures 10 by 10 by 10. So the volume of the cube is 10 times 10 times 10, which is 1,000 cubic centimeters. So if we can find the relation between 1,000 milliliters and 1,000 cubic centimeters, we'll know how to convert these two unit measures. All right, I can't pour it, but they say they have proved that if they pour the liquid into the cubic, it fills the cubic perfectly. So that means 1,000 milliliters equals 1,000 cubic centimeters, which is also 1 cubic centimeters equals 1 milliliters. So this is for you to remember. Each 1 cubic centimeter equals 1 milliliter. Now if you convert these two, it's going to be pretty easy. 850 cubic centimeters would be 850 milliliters. 1,025 cubic centimeters would be the same number of milliliters, and you may want to write it in a different way. You want to write it into liters and milliliters. And in the same way, converting liters into cubic centimeters, 2 liters would be 200 milliliters, 2,000, and it would be 2,000 cubic centimeters. Isn't that easy, guys? For questions, for word problems, I don't see how you could have difficulties, but we're going to talk about this one briefly. So this rectangular tank is filled with water to a height of 4 centimeters. How much more water is needed to fill the tank completely? So what we do is we find the capacity of the whole tank, which is length times width times height. And then we find the volume of the liquid, length times width times the height of the liquid, which is 4. And then we do subtraction, capacity minus volume, and you will get the volume of water needed to fill the tank completely. Is that okay, guys? I feel like it should be okay. If you need, you can go back the video and watch it again. If you find anything confusing.